This video will focus on both the activity portion and lesson portion of Chapter 1.1. So before we get started, I want you to pause the video and try to figure out if it's greater than or equal, or I'm sorry, greater than or less than for each of these 6 problems. Once you've written them all out, please press play and then see if you are correct. All right, so now that you've checked them out, let's go and look. So first of all, 14 is greater than 12. 36 is greater than 26. Negative 2 is greater than negative 5. Negative 8 is greater than negative 15. 13 is greater than negative 10. And 19 is greater than negative 20. The only one that might be problematic here is one that's like negative 2 and negative 5. Because if we think about integers, positive, the bigger number usually represents the larger number. But in this case, remember, we are discussing negative values. So if I look at 0 is right here, then I go negative 1, negative 2, negative 3, negative 4, and then finally negative 5 is like over here. If I look what's closer to the 0 in this situation, 2 is actually closer, therefore 2 is a greater value. So that's that. The essential question for this entire chapter is how could you use integers to represent the velocity and speed of an object? So it's a really important thing to define velocity and speed. And what you might want to do is pause this and look in your book at the various definitions before we continue. For the next one, it asks you to go through here. You're gliding to the ground wearing a parachute. The table shows you a height above the ground at different times. So at 0, I'm 90 feet above. At 1 second, I'm at 75, 260, 345. Describe the pattern. So what's happening every single time? And if I look here, of course, this is going up by 1 every time. And down here, it appears that this is actually going down by 15, right? So it's going down 15 every time. So if I want to figure out 4 seconds, what I might want to do is take 45 minus 15 and get 30, and so on. And it says, how many feet do you move each second? Well, I'm actually moving, I'm going down 15 feet. And then when will I actually land on the ground? Well, I'm going to land on the ground at, let's keep going here. So if I go 5 is 15, and then 6 is 0. So I land on the ground at 6 seconds. So I move 15 feet, so negative 15 feet every second. And how many seconds until I land on the ground? It'll take me exactly 6 seconds. Now it says which integer represents your speed. In this case, we're going to say that the speed is actually 15. Okay, so the integer represent is 15 because it's speed. But the next one says velocity, and it says, should this be represented by a positive or negative? Well, I'm going down, right? So I'm going to make this a negative. So really, for speed, it doesn't matter if it's negative or positive. It will always be the positive value. We call that the absolute value. For this one, for velocity, however, it wants to tell if it's going up or down. So since it's going down 15 every 1 second, we'll say negative. And then it says what integer should represent your velocity? Well, in this case, it should be negative 15 over 1. So velocity is the actual value. Speed is the absolute value of it. So it's always going to be a positive answer. So here's the next one. Same kind of thing. And it says here, describe the pattern on the table. Okay, so for the first 40 feet. So if I look here, it's going up by 1. And then down here, it appears that it's going up by 4. So if I keep on doing this, so 4, 5, 6, 7, 8, 9, 10. And then on the side, I'm going to have 24, 28, 32, 36, and 40. Now, of course, this is a little off here. So if I look here, 8 is 40. So every second it appears that it's moving 4 feet per second. What integer represents the speed? Again, it's a positive value, so it'll just be 4. And then the next one says, do you think the velocity should be negative or positive? Well, this time the actual value is a positive. So remember, velocity is actually if it's going up or down. So this is going to be a positive number first of all. And we'll say that it should be 4 over 1. So that's what this is right here. All right, so with this table, we're going to go through and do the same thing that we've been doing. And if we look here, this one's going down by 120 every time. So it says describe the pattern. It's going down 120, right? And then it's over, so I'm going to say minus 120 feet over 1 second. And it says what will be the speed of the parachute. Well, the speed again is going to be the absolute value. So it's 120. And then what integer represents the velocity? So again, this is what it actually is. So it's a negative value in this case. So we'll say negative 120. And then how are these integers similar in the relationship to 0 on the number line? Well, if I put a number line up and I have 120 over here, oh, that should be a 120, sorry. Press again. So I put 120 on this side, and then negative 120 on this side. Right in the middle between these is a 0. So the distance from 0 is 120 in both directions. However, one is positive and one is. So here's an example of velocities. If you look here, notice that there's some positive values and negative values right here. And then we're going to look at the actual speeds here. So if we look at velocity of object A, this is going to be greater than this. This right here is greater than this one. And this here is greater than this one. But it says the speed. If I look at the speeds now, remember this is the absolute value of this. And that would mean that if I look here, this would become a positive 5, and 5 is greater than 4. That's why that works. 15 is greater than 10 if it's an absolute value again for speed. Then that's why this is greater now. And this negative 15 turns into a positive 15 when we talk about speed. Again, it's the absolute value of it. So now I want you to find the absolute value of these terms. So do me a favor, pause the video for a moment, and then check it out. When you're done, press play. All right, so now that you've worked it out, here are the various answers. 15 is 15. Negative 23 becomes positive 23. 7 is still 7. Negative 35 is 35. Negative 43 is 43. 0 is 0. 39 is 39. And negative 212 is 212. And this is to show you how absolute value works, just like we showed before. If I look at the number 4 and negative 4, they're exactly 4 units away from 0. Absolute value just means what is the distance from 0 on a number line. And that's why the value is always a positive value. So find the absolute value of 2. Well, we know it's 2. The absolute value of 3. So here it is. So negative 3 is right here. Again, 0 is right here. So positive 3 has got to be over here somewhere. And this is the absolute value because, again, it goes from 0 to 3. And then from 3 to 0. So the distance is 3. Find the absolute value of 7. Again, if we have our number line, we'd have, it's 7 from 0. Negative 1 is 1 from 0. Negative 5 is 5 from 0. And 14 is 14 from 0. Compare 1 and the absolute value of negative 4. Well, in this case, it's 1 from 0, and this is 4 units from 0. So here is negative 4 on the number line, right, is over here, but the absolute value of it is positive 4. So how would I compare these two? The absolute value of negative 4 is greater than 1. All right, so then if I look at this one here, if I have negative 2 and negative 1, this is the absolute value though, so this becomes positive 2. So it should go. This one should be negative 2 would be greater. This one here, negative 7, is smaller because it's not the absolute value, is it? This one here, negative 9, the absolute value, so it should be equal. This one here, 11, is still bigger than the absolute value of 10. So then I look here, so it says, which substance in the table has the lowest freezing point? If I look at the lowest freezing point, it looks as though it's going to be airplane fuel, of course, right? And it says and then put an order from least to greatest, which I just did. And then is the freezing point of mercury or butter closer to the freezing point of water, which is 0? So if I look here, butter, which is 35, and mercury is negative 39. Which one is closer to 0? And I see that butter is. Is the freezing point of airplane fuel or KNOx closer to the freezing point? So if I go back, so airplane fuel or butter. So if I look here, it looks at, or I'm sorry, KNOx, these two. So which one's closer to 0? It looks as though airplane fuel would be. And then finally, the freezing point of vinegar is negative 2. Is the freezing point of vinegar or honey closer to the freezing point of water? So again, I have to go back. So vinegar is negative 2. This is negative 3, right? So it looks like negative 2 would be closer to 0. So it looks like vinegar would be. That's the answer.